everyone. Today we are to discuss the Zener diode. The Zener diode is a special class of diode and it is symbolized like this, and it is just a typical diode, but with a speciality. Now the speciality of a Zener diode is that it is heavily doped at both P and N side, and now it operates in the reverse bias. When we heavily dope both P and N, the width of the barrier is reduced, so we have a thin barrier. Now a thin barrier, as we know, can be achieved with heavily doping P and N sides, because the width is directly proportional or inversely proportional to the doping level. Now as we reverse bias it, what happens is that after a certain voltage, when we rise the biasing voltage in the reverse bias, then it arrives to its Zener breakdown point. Now for those of you who do not know what is a Zener breakdown, let's discuss that first. If we consider a PN junction reverse biased with high voltage where V is very high, then what happens is that it exerts a very high electric field because of the ionization of both the P and the N side of the barrier. Now the ionization causes a very high electric field, and under the high electric field the atoms which are bound together, generally they break apart. Those break apart, and you can say the crystal ruptures. Now when the crystal ruptures, then there is a high amount of electrons released. There is a huge amount of electron released, and there are a lot of ions as well, and those electrons causes a huge flow of current. Usually in PN junction, in usual diodes, we do not want to attain the Zener breakdown point, because due to this high current the diode may be hampered. But in Zener diode it has a high power dissipating capacity. A high power dissipating capacity causes it to withstand up to 50 watt of power, so it can stay in the breakdown condition for a long time and still not get hampered or destroyed due to the high flow of current. Now we know that for a usual diode at least 150 to 100 volt is required as a Zener breakdown point. But if we see the Zener diode, then we do not need that much of point. We need just 5 volt to 12 volts. How does that happen? Well, because of that narrow channel we have, now between that channel we have a voltage, suppose of 5 volt, a voltage, but with less width. So as we know, E equals to V by D, or the electric field intensity is equals to the voltage per unit length. So which makes us understand that with small d or with small w we can have a high value of E even at a low voltage V such as 12 volt. Now that causes it to break down so early, and which is useful to us. Now for all over the world it is known as an application of voltage stabilizer. So how does it happen? So for a Zener diode to work as a voltage stabilizer, there are certain rules. Rule 1. It has to be operated at a reverse bias, which is obvious. Still, it is the rule. Rule 2. We need a VCC greater than the threshold voltage or the breakdown voltage Vz. This is rule number 2. Rule number 3 is there has to be a resistance in series with this series resistance. Now as we have a series resistance with Vz, now rule number 4, which is Vz, whatever Vz is, that will be the voltage across the Zener diode. So the voltage across the Zener diode will be constant. Voltage across Zener diode equal to Vz. Now with these rules we can now easily build our own stabilizer. How? Let me show you. Let us take a voltage V and let us make an arrangement where we have a series resistor and a Zener diode. Now let the Zener diodes Vz be equal to 5 volt. So there will always be 5 volt across this diode. So if we take a load in parallel with Vz, then we have R equals to 10, suppose ohm, RL equals to 20 ohm. So if we take 10 equals, this is equals to 10 volt, then across this also it will always be 5 volt. It will always be 5 volt across this load, because this load is in parallel to the diode. Now let's find out the current across this. Let us denote it as IS. IS will be equal to 10 volt divided by 10 minus this 5 divided by this 10 ohm, which gives us 0.5 ampere. Now when we find out the current IL, the load current, which is 5 volt divided by 20 ohm, which is equals to 0.25 ampere. So here we have 0.5 ampere coming, and out of that we give the load 0.25 ampere. So the Zener diode passes the rest of the current, which is the remaining 0.5 ampere. So IZ will be equals to 0.25 ampere. So that's it. So we have a varying current but a constant voltage across this load. So this is how we use our circuit to provide a constant voltage supply or a voltage stabilizer supply. So now this is how we use. Zener diodes are used all across the world as a stabilizer, and it has many applications. Its VZ depends from 5 to 200 volts, and its power can be from half watt to 50 watt. Now this is all we have to share about Zener diode. Now for more videos, please tell us about the topics you want to know from us, so we will discuss them as well. Well, thank you, and please like our videos or subscribe to our channel.